Okay, this is 9.6 homework help on linear programming. The first problem gives us this quadrilateral, and it gives us the corner points, which is nice, and it gives us this maximization equation right here, and it wants to know the maximum value of this equation over these values. So if we're going to maximize this, we need to test all the corner points. Now these are both negative, so my guess is that this one's going to be the maximum because of the fact that these are negative. So we want smaller values. Smaller negative is a bigger number. But let's just try it out real quick. So the point 418, when you test that, obviously that's going to, the value for z is what we're looking for. It's negative 5 times the x value of 4 minus 5 times the y value of 18. And that gives us negative 110. Now I'm just going to do the other points real quick. I'll pause it to save time and show you the work. And sure enough, then the smallest, or I'm sorry, the maximum value is negative 70 at the point that we thought it would be at. And that corner point is 10, 4. Okay, here's a similar problem. This time the shaded region's on the other side, and we want to find the minimum value of this equation. So we need to test these 3 points again, like for example 0, 30. If you want to test that point into z, you just plug it in. So x goes in for x, and y goes in for y, in which case, in this case, you get 90. Now I'll do the other ones real quick. And if we find that the minimum is 19, and that happens at the corner point 2, 3. So right here. Okay, the next one we have to graph ourselves. So I'm going to draw a graph here. Now it says x1 and x2, but think about this as like x and y. So we're going to graph this. Now I know I need to just do the first quadrant because you know, you can see that x1 is bigger than 0 and x2 is bigger than 0. So here's the equation we need to maximize. And here's the constraint region that I need to graph. So to graph this first equation right here, what I would do is plug in 0 for x1, and that gives me 10 for x2. Plug in 0 for x2, and that gives me 2. So I'm going to graph those 2 points. 2, 0, let's say, is right here, and 0, 10, let's say, is up here. And then we do the same thing for the next equation. So there's that equation, which I'll draw in red. Next equation then, plug in 0 for x1, and you get 3 for x2. Plug in 0 for x2, and you get 15 for x1. So 15 comma 0 we'll say is out here, and 0, 3 is right here. So if we were to graph both of those, we get this region right here. Now we want all the values that are less than this, so if you plug in like 0, 0 and test it, you find that this is the solution, so I'm going to shade in here. This is my constraint region. Now I do need you know, x1 and x2 to be bigger than 0 as well. So I'm graphing to the right of the x or the y-axis and above the x-axis. I do need to find this intersection point. I'll find it by solving the system of these equations right here. So 5x1 plus x2 is equal to 10, and x1 plus 5x2 is equal to 15. Now I'm going to multiply one of these equations by negative 5. I'll do the first equation and write it right here. So negative 25 x1 minus 5x2 equals negative 50. And then I'll add those 2 equations together. So that gives me negative 24 x1. These cancel, and you get negative 35. Divide both sides, you find out that x1 is this weird fraction for me, 35 over 24. And I do need to plug that in to find x2. So when I plug that into like this equation right here and solve for x2, I get about 2.708 or 65 over 24. So there's my that point right here. So now once you have your system graphed with your points, your corner points all listed, now you can try these corner points to maximize this. Now it's probably this answer, but we should try all of them really quickly. So if you try the point 0, 3 for example, then P becomes 6 times 0 plus 11 times 3, and that gives you 33. Now we can try the point 35, 24. 65 over 24, and I'll just show you the work for that real quick. That's 38.54, and then we can try the last one, which is 20, and just plug that in. 6 times 2 plus 11 times 0, which just gives you 12. So in this case, they wanted the maximum value. Maximum value is at the corner point we thought it would be, this one right here, which is 38.54. Okay, the last problem then is a bunch of reading, but it says we're going to order microwaves and stoves. So M and S will use their two variables. It says each microwave requires 1.5 hours to unpack. So there's an equation they're giving us, 1.5 times M for the number of microwaves, plus 3 hours times the number of stoves. And now I'll look for the other piece of information for hours. So it allows 84 hours employee time. What that means is that we have to be less than or equal to 84. So there's one constraint equation. Now it says that their space is limited to 40 items, so that'd be the number of microwaves plus the number of stoves has to be less than or equal to 40 is another constraint equation. Now obviously the number of microwaves can't be negative, and the number of stoves can't be negative, so I guess it shouldn't even be 0 really. So there's two other constraint equations, I guess. Now they give us a profit equation at the end. They say that microwave yields a profit of $105 each, plus stoves yield a profit of $200 each. So there's the profit equation we're trying to maximize, or maximize. And so we're going to need to draw this constraint region set up by these 4 equations right here. Obviously we're only talking about the first quadrant because we want to talk about positive values. So I'm going to graph these two lines just like we normally do by finding x and y intercepts. So if I plug in 0 for M for the first line here, I get 84 divided by 3, or 28 stoves. So we'll do M on this axis, microwaves on this axis, stoves on this axis. So 0.28 is up here. I'll call that 28 right there. We also want to do plugging in 0 for y then. If we have 0 stoves, how many microwaves do we have? That's 84 divided by 1.5, or 56. So 56, let's say that's over here. So there's our first line from our first equation that we have to stay under because we're constrained by. So if you pick 0, 0 in here, that is less than or equal to 84, so we need to shade this part. So now this line is 40 and 40. So let's say this is 40 and this is 40. If you plug in 0 for microwaves, you get 40 stoves, and if you plug in 0 for stoves, you get 40 microwaves. So that's this line here. Now obviously we need to shade on this side of that line as well, so the overlap part is going to be this region here. Now we do need to find this intersection point right there. So obviously to find that, we're going to solve this system right here. So I would imagine these as like equal signs to solve the system, and multiply one of these equations by -3, for example, will work. This would be -120. Now you can just add these together, and this gives -1.5 m. These would cancel, equals -36. Divide both sides by -1.5, m equals 24. So this point is 24, comma, and then plug it back into any one of these equations. The easiest one is the original one, m plus s equals 40. So then we're looking at 16 stoves. So there's the intersection point, which is going to be helpful. Okay, so I'm going to write down my corner points. My corner points are 0, 0, which obviously that's not going to maximize profit. It's going to be one of these 3 points, this point, this point, or this point. My guess is it's going to be this one, but we'll find out. I'll write down these points. First of all, I have 0, 28 is one of them. I have 24, 16 as one of them, and I have 40, comma, 0 as one of them. So let's go ahead and plug these in. I'll show you the work for both of these. 0.28, if I want to look at the profit for that, that's 105 times 0 plus 200 times 28, and that gives you a value of 56,000. Now you just do the same thing. 105 times 24 plus 200 times 16 gives us 5720. And then the last gives you 4200. So obviously we're looking at this point right here, the point we thought, and the maximum profit is 5,720. The number of stoves then is our Y value, which is 16, and the number of microwaves is what we used for our X value, which is 24.